Okay, and what should this be equal to? Well, this should be equal to x alpha plus the conformal killing vector, which for the transformation that we're looking at is omega alpha beta x beta. And if we compare these two expressions, 1 times by x alpha is just x alpha. So those match. And that means that this term sitting over here should match this term sitting over here. So let's put down that requirement. So the omega alpha beta x beta should be equal to I over 2 omega mu nu m mu nu x alpha. So from this equation, we should be able to tell what is the action on x alpha. So let me tell you what I read off, and then we'll check it together. So I find that if I take I m mu nu to be equal to, on x alpha to be equal to minus delta alpha nu times by x mu plus delta alpha mu times by x nu. This does the job. So let's check it. I'm going to outline this equation in blue. So that's what I'm going to check now. And the way that I'm going to check it is just by checking that it does the right job. So if I take I over 2 omega mu nu m mu nu onto x alpha, well, I've got 1/2 omega mu nu, and then what remains is I m mu nu x alpha. I'm going to take this from this blue boxed equation. So this is minus delta alpha nu x mu plus delta alpha mu x nu. So what is this equal to? Well, when the delta alpha nu contracts into the omega, we'll get an omega mu alpha. This will be over 2. There'll be a minus because that first term is negative, and we will have an x mu downstairs. Plus, when we multiply into the second term, we'll have an omega. Now the mu gets turned into an alpha. We'll have a nu. This is over 2. This contracts into x nu. Now we can swap the alpha mu on the first term, and that'll change the sign. And then if we relabel the dummies to maybe beta, we get omega alpha beta over 2 x beta. So I've relabeled the dummy index mu to a beta on the first term, and I swapped the indices on alpha. And then I've got plus omega alpha beta x beta, and all I did in the second term was relabel the dummy index. Add those two together, what do we get? Omega alpha beta x beta. And this is perfect. Why? Well, it matches the left-hand side of this equation. So the equation now boxed in red. This equation was meant to be telling us about the action of mu nu. That's exactly what it's told us. Now, the good thing is, so we don't need this blue anymore. We just use that to verify that the equation boxed in blue was correct. So let's just remove that now. Now, the good thing is this equation boxed in blue is going to tell us exactly what the generator is. Good. So what does this equation look like? Let's maybe go back to black. Well, these delta functions, we know where those come from. Those come from acting with a derivative. So if we want to get this delta alpha nu, we know we should have a d nu inside the mu nu. And we've got an x mu downstairs. So let's put an x mu downstairs. And then there's a minus sign. Well, an I times by an I will give us a minus sign. And then for the second term, we've got a plus. If we want to get rid of the I, we'll need a minus I. Minus I times I gives us a plus. We want an x nu, so let's put the x nu in. And then we want to get a delta alpha mu from the x alpha. So we need a d mu acting on the x alpha. So this will be our m mu nu. And indeed, if we now check, does this black boxed equation for m mu nu satisfy the equation in blue? That's a straightforward thing to check. You should check that it really holds. Now, if you look in some textbooks, you'll notice sign differences in various places. So what we call omega, they might call minus omega. When we take a look at mu nu, they might smuggle in some extra signs. So all of these different signs are different conventions that people can choose, and they're related to the different way that we split the transformation up into a parameter and a generator, and even conventions, what we call a positive rapidity, what we call a positive rotation angle, and so on. So it is important to use one set of conventions and to use them consistently. But when you look at somebody else's work, if they're using a different set of conventions, you should be able to translate from one set of conventions to the other. So if you're looking at other sources and they get a different expression for this generator, mu nu, well, you should be able to understand where is that difference coming from, and you should be able to track down which of our conventions are different to their conventions. Now we've got the generator for the Lorentz transformations, mu nu, and we've also got the generator of translations, p beta. Great. So now we'll start moving on to scaling, and then we'll do the special conformal transformation, and then we'll have the complete all of the elements of the Lie algebra.